So we've studied already inequalities, the concept of less than, greater than, less than or equal to, greater than or equal to. We've looked at those 4 inequality symbols. Now let's figure out how we would utilize them in a word problem setting. Right? How would they show up in a word problem? So that's what we're going to figure out. See this? Sure. All right. That's weird. Okay. So let's just jump right into this now. So we have 4 things. At least, at most, no more than, no less than. So these are word problems that don't involve equalities anymore. So you don't want to know, what is the value that causes the area to be 72. Now we're looking at things like, at most, how many cans of soda should be produced to make a profit margin of this much? That would be at least, really. At least how many? At most, how many cookies can you eat before you consume 800 calories? So that's, in that case, a less than or equal to symbol. So when you look at these terms, you have to think what they actually physically mean. So at least, if I say at least, how many do you have to have? What would the symbol be in that problem? If I said at least, how many cans of soda should you produce? Yeah. It'll be a greater than or equal to symbol, either one of those. Okay, greater than or greater than equal. And if it says at least, it would be greater than or equal to, because you could be that value or more than that value. At most means you're getting a cap, so it's got to be less than or equal to for at most. You have a cap or a limitation. Less than or equal to. It depends on the context. That's why I'm putting them both down, even though it's really less than or equal to or greater than or equal to now. How about no more than? What does no more than mean? In the problem, the profit is no more than this much.
Less than?
Yeah, that's also going to be less than or equal to. And specifically, actually, that one will be just less than, really. And then the last one, no less than, means it's got to be more than. Okay, it's the opposite. You're using like a double negative there. So those 4 symbols are really where they're coming from here. We have less than or equal to, greater than or equal to, all coming from those phrases. So let's take a look at a first problem to see how we can dissect it. When in doubt, what should you do? When you're not sure which symbol it is, what should you really try and do? In a word problem, what might be a useful thing to do? If you're not sure which symbol to use. Maybe give numbers for certain things you're not sure of. Try values to start. When you're thinking about like an SAT strategy, that's a very useful one. So you might be able to try values to see if it becomes greater than or less than a certain value that might indicate which symbol it is to you. So let's start with this first one. A store charge $5.50 for calculators sold, and a delivery charge and a delivery charge for $25 for the order. If the store sells calculators at $8 each, how many must they order and sell to produce a profit of at least $86? Profit of at least $86. So we have to start this problem. And this might seem difficult to you, but it's not. It really is not a difficult problem. But we have to first start with the definition of the word profit. What does profit mean? This is something in math that you should really learn early on, so that's why I kind of throw it in with this lesson. What should it mean?
Income.
Income, okay, give me more than just income. Specifically profit.
Positive.
Good, the positive income. So what are you comparing? 2 things.
It's the amount of money that you make subtracted by the amount of money you spend.
Good, so and that's what we were talking about with positive income. So profit is the money you make, which is called revenue, minus your cost. This is like a mathematical or economics definition of the word profit. Revenue minus cost. That's exactly what Eduardo and Moro just told us. Okay, it's the amount of positive. Now, profit can be negative, right? And that's when you're not at a profit, you're at a deficit. So you could lose money, obviously, right? If your profit turns out to be negative, that means you've lost money. It means simply that your cost is more than your revenue, right? If you're paying for more stuff and you're not making enough money, it doesn't make sense to continue the business. So we're looking for a profit of at least $86. So if I know that the profit should be $86, I can make this statement also. At least $86. That's true, right? The profit should be greater than or equal to 86. At least means I can make 86, 87, 88, 89, 100, 90, 91, etc. for the profit. Now, based on our substitution principle, what can the next line look like? I'll give you a hint as to what to be making the next line look like. Substitution principle. Regina, what do you think?
You're going to substitute our money
Agreed. Since the definition of profit is revenue minus cost, replace profit with revenue minus cost. So we need a revenue function and we need a cost function. Revenue and cost functions. Can we identify what they are with this problem? Let's take a look. Tell me what is important for the revenue function. What part of the problem, words specifically, are important for the revenue function? What do you think, Altina?
The store sells a calculator, it's $8 each.
Yeah, $8 each, right? That's how much they're selling it for, what they're bringing in. So there's the revenue part right there. So we want $8 each. So let's highlight that to show that this is part of our revenue right here. How about the cost? How about the cost? What do you think for cost? What's important for cost? Somebody else? It's fine. I'm glad you answered the last one. Somebody else?
$30
Say again?
$30
Okay, but keep in mind, you're on the right track, Helen. The delivery is a one-time fee, right? The calculator's per item. So how would you represent it? You're on the right track. Come on, figure it out. Well, we need some sort of a variable, right, involved here? Good. Very good. See, you got it easy. 25 is a one-time charge. It says it's a delivery charge, right? When you get a delivery of a shipment, you don't pay per item. You pay for the delivery. And you've done this before when you order things online. You pay for an overall delivery. So the delivery charge, it says, for the whole order is 25, and it costs you $5.50 for each calculator. So here, that's going to give us the cost function. Now, let's go ahead and write those out. So revenue is $8 for each calculator sold. The cost is $5.50 per calculator plus a $25 initial cost for the shipping. So what should my let statement be at the very top here? What should my let statement be, Alex?
Let X equal the number of calculators bought.
Good. Number of calculators, and it's bought/sold, because we're assuming that all are sold. We're going to do a math project in the second and third quarter that involves manufacturing and thinking about things like, oh, what if you have leftover inventory? What do you do with it? Well, you get charged to store it. Here, we're assuming all the inventory is sold. Is that clear what I'm saying? Okay, X is representative of how many you buy, and you assume you sell them all. Because if you don't sell them all, this function doesn't make sense. And now go ahead and solve this. How many calculators must be ordered and sold to produce this profit of at least $86? I'll catch up to you. First step is the most important. If you make a mistake there, you're going to run into trouble, so make sure you make the right step there. After this, it's simple algebra. Move the 25 over. 8 minus 5.5. 8 minus 5.5. Divide through. So I'm done. That's it, right? I need 44 and 4/10 of the calculator. 44 and 4/10 of the calculator. What would my verbal statement be? Remember on the last test, I think one of you asked, like, it says answer with a verbal statement. Here I want like something where it's a conclusion, because this is not obviously your answer, right? Can you order 44 and 4/10 of a calculator? No. Obviously not. What do I do? What do I do? Same two guys, you answered already. You answered already too. Somebody different. Christian, go for this one. Okay, but in this case, read the statement. X is greater than or equal to this number, right? So which way do I have to round? It says greater than or equal, so I have to round which way? Oh, it's got to be up. Because normally you would round this down, wouldn't you? If you rounded this to the nearest calculator, wouldn't you round it to 44? But if you only sell 44 calculators, you're not going to make a profit. This statement here says we need to sell more than that many calculators. What's the next amount of calculators more? Yeah, 45. Okay, again, at least 44.4 means it's got to be more than that. So it's not really rounding, it's more reading the inequality statement and using the next integer. Like we're rounding up here. There's a phrase in computers it's called, it's like a ceiling function. There's a floor and ceiling function. A floor function rounds down, a ceiling function rounds up. In this kind of a problem, you have to round up. Because you're looking at making at least that much money. So you have to sell at least that many calculators, which means that many or more. The only thing more than 44.4, the next thing more than that is 45. So if I sold 46 calculators, am I going to make my goal? If I sell 46 calculators, sure. 47? Sure. Anything greater than this, it'll make the goal. But we want to just know what that minimum value is, right? How many times have people done this? I hope none of you have done this, but I've had students in the past that have said, can you tell me what the minimum grade I need is on the final to pass the year? And like that's like the worst question here as a teacher. You're like, wow, so you're just gonna like try to get like 50 pretty much, you know, kind of thing. So the mentality is like, what do you actually need to get to that mark? In this case, you need 45 calculators to get to the $86 profit mark. But obviously in a business, in this case, you want to optimize or maximize your profits to make more than 86. So this is just the minimum that you need. You could get more, and more would work. But any less than that would not reach your goal or your target value. Okay, and you can check by plugging it in. If you try something like 44 and plug it in up here, you will not get a number greater than or equal to 86. You'll get a profit that is a little bit lower than 86. All right, let's look at this one. Find 4 consecutive even integers whose sum is between 20 and 30. 4 consecutive even integers. Now, obviously, a lot of you can figure this out in your head. I know that, trust me, by inspection. But I want you to practice setting it up. I made it easy on purpose. Okay? Now suddenly, instead of between 20 and 30, what if it's between like 260,000 and 400,000? You know what I mean? The numbers change. You can't do things in your head like that. So treat this as if you don't know the answer, because I know a lot of you can see the answer right off the bat. Okay, 4 consecutive even integers. What should I call the first integer? And then after that, Helen, what should the next integer be? Etc., right? No, keep going. And then? Okay, there's my 4 consecutive even integers. What if it had said 4 consecutive odd integers? What if this was looking for 4 consecutive odd integers? It's the same thing. Some of you mess this up on your homework/quizzes. You use like +1, +3, +5. Those numbers differ by 2. But the concept is that since x is the smallest, its next consecutive odd or even has to be 2 more than it. So it's always going to be a +2 there, when it's consecutive odd or even. If it just says consecutive integers, it's +1, +2, +3, +4.
So no matter if it's even or odd, it will just be.
Because all odds differ by 2. Evens differ by 2. And this is using a differ. It's not a statement of what the number is itself. Okay? So we want even integers whose sum, so add them together, 4x plus 12 is between 20 and 30. How do I write that? How do I write, so this is the sum right here, right? Everybody can do the math in their head? That's the sum. How do I write it between 20 and 30, Alex? What do I do?
You just do 20 is less than 4x plus 12, which is less than 30.
Very good, Alex. Well done. Okay, since it says between them, it doesn't say including them. We don't use less than or equal. So I like that you only use less than here. If it said between 20 and 30 inclusively, or including those values, something like that, you would put a less than or equal to symbol in those spots. But it doesn't say that. It just says between 20 and 30. So it's got to be in there somewhere, not including 20 or 30. Get rid of the 12. Get rid of the 12, please. Divide by 4. What's the answer? What's the answer for x? Think about what x was defined as. To start the problem, what was x defined as? What do you think, Francisco? It's the smallest of them, right? And it's what kind of an integer specifically? Even. So what are the integers between 2 and 4.5? What are the integers?
4.
4. What other integers are there? And 3. That's it. 2 is not included, right? Keep that in mind. 2 is not included in the solution set here. So it's either the number 3 or 4 for x. That's the only possible answer. 3 or 4. The only one that's even is 4. So x has to be 4 in this case. If x is 4, it means the numbers are 4, 6, 8, and 10. Again, I made sure that this problem did not have an inclusive endpoint because that would have given a multiplicity or multiple answers, right? The answer would be 2 or 4 if this were less than or equal to. Because 2 is even, and then 4 is in here also. 4 is also even. You would have multiple answers. Okay, so there's only one actual answer for this. So we understand between, right? Between, the concept of between two values. All right, example 3. During the first 20 miles of a 50-mile bike race, John's average speed was given. What must his average speed be to the nearest mile per hour during the remainder of the race if he's to finish in less than 2.5 hours? So time needs to be less than 2.5 hours, right? Time needs to be less than 2.5 hours. That's the whole key here. So I have to consider what's physically happening. Can I draw myself a quick picture of this again? I think that would help. In the very beginning, it's 20 miles long. It's 50 miles total. So there's my statements right off the bat. I'll put units so I know what units I'm looking at. So I know those are my distances. Then I know that in the first 20 miles, the average speed was 25 miles per hour. So I'm going to put that in that area right there. And the question says, what must his average speed be during the remainder? So R2 equals question mark. So that's what's given already, or what I'm looking for and given. And then it says, what must it be during the remainder of the race if he is to finish in less than 2.5 hours? So that's my statement on the far right. That's all I can write so far. I don't have enough information to write anything more than that. That's all I can write so far. It's all that's given in this problem. Next. What do you think would be a useful technique in this problem? Since I'm looking at times, I'm looking at a time restriction. What should I do with my D equals RT formula? If I'm looking for time, what do you think I should do? What do you think I should do?
Time equals distance over rate.
So solve for T. Again, I have a time restriction. The total time is 2.5 hours. So it would make sense to say this. That would also make sense because what's the total time? It's the sum of time 1 and time 2. Total time is less than 2.5 hours. Substitution principle tells me that I can replace total time, given right here, with T1 plus T2. Because it's the equivalent. There's 2 parts of the race. So how do I find the total time? The first time and the second time. How do I find the first time? Using these numbers. Time is defined, as we can see here. If we know that D equals RT, then time equals distance over rate. So this is distance over rate. This is distance over rate. And we have our value there. So this is very, very, very similar to what we did in the last couple sections, 1.8 and 1.9. We were given a governing formula we wanted to use, and that governing formula sometimes was time 1 plus time 2 equals time total. Or sometimes a governing formula was D1 plus D2 equals D total, right? Other times we were told that 2 objects were moving like next to each other and catching up. There we could say D1 equals D2. This is one of our several governing formulas from this section. Total time is less than a certain value. What's the only unknown here? What's the only unknown here?
R2.
R2. Okay, so it's a matter of just solving at this point. How do I solve for R2? Well, I could do it several ways. I could first take 20 out of 25, make it a decimal, and move it over. That might be useful, right? So let's get rid of it. What's 20 over 25 as a decimal? What's 20 over 25 as a decimal? Yeah. The reason I'm making it a decimal is only because on the right side I have a decimal also, right? I'll move the 0.8 over. Becomes 1.7. Subtract 0.8 and make that 1.7. How do we get R2 by itself? We've done this a couple times. Yeah, multiply by R2. How do I get rid of the 1.7? Divide by 1.7. So this is what the last line will look like. It'll say 30 over 1.7 less than R2. The final statement will say this, 17.64. If I read this final statement, it says R2 is greater than, because I'm reading it this way, R2 is greater than 17.64. What's the nearest integer greater than that? 18. So the rate must be at least 18 miles per hour. You notice there's one more example, right? You see that? There's one more example. What do you think you should do tonight? Do that example. If you have trouble with it, look at my notes, look at the video, do the last example at least at some point. You probably want to look at the video, it might help. So maybe look at my video for the last example and then do the homework for Thursday, please. I think I put homework due tomorrow because Thursday, what's due? So I made this homework tonight, so it's due tomorrow. So what do you have to do? Submit it electronically, please. You're not going to see me to submit homework. So hard copy people, just take a picture for tonight at least and submit it electronically. I made this homework due tomorrow on purpose. Okay, and then the other one's due Thursday. Office hours are Thursday, not Wednesday this week. I emailed you about it, just for a heads up. PSAT. I will do example 4 on the homework tonight, submit that, and then submit the other problem set before Thursday.
Wait, but the problem setting is still more hard copy.
Yes, because that's Thursday, we'll have class. So do that. Yep. Forgot to mention a project. 2 people didn't submit their project. Everybody here submitted their stuff, right?
I have a question for the project.
Yeah.
Does it need to be actual data or real data?
I would love for you to get real data feedback. I really would.
So if that's better, can I like slightly tweak?
Sure, absolutely, yeah. I'd rather you get real data and utilize real data than have to like make up data. So if you need to change it, that's totally fine.
Alright.
But like, what was yours again? Remind me.
Like picking NBA.
That's right. Okay. Yeah. So if you want to tweak it to another sport or
instead
something
of, like,
different,
making for this year, I'll do like last year's stats.
absolutely, that's totally fine. Yep.
See, I